Hey everybody. In this video we're going to be talking about a different method to solve these systems of equations. So let's start with this example. Here's a system of equations and I'm telling you that it has this solution, -1, -2. And again, we can verify that that's the solution if we take this x value and plug it into both of the equations in place of x and take this y value and plug it in for y. We should get true statements. So we should get 4 in the first equation and 5 in the second equation. So again, that's what it means to be a solution. So we can solve that with substitution like we did before, and now we're going to look at a different method that's going to be more helpful when we have more equations with more variables. So it's called matrix row reduction, and here are the allowable row operations. So these are the three things that you can do to solve a system of equations using this method. First of all, you can switch any two rows. That one is sometimes useful. You can multiply or divide any row by a non-zero number. You cannot multiply by 0. You can never divide by 0. That one's sometimes useful to make the numbers a little bit smaller. But the most useful one is the third one. This is the one we're going to use pretty much all the time. You can add or subtract a non-zero multiple of one row to a non-zero multiple of another row. All right, and that'll make more sense once we do an example. But here's our goal. We're trying to get zeros in certain places in the matrix, and you'll see why that's helpful. A good rule of thumb is to turn numbers into the same number and then subtract. That's going to give you a 0. And in order to do that, you can always come back to the idea that you can just multiply them by each other. That will turn them into the same thing. All right, so let's look at this same example, and because we know what the answer is going to be, and we'll solve that, and you can see how we're going to use these row operations. So first of all, here's the coefficient matrix for this example. So you'll notice I take those equations, and I just take the coefficients out. So I'm just taking the 2, the -3, and the 4, and it gives me this first row, 2, -3, 4. And then I take the 3, the -4, and the 5, and it gives me the second row, 3, -4, 5. All right, so you're just taking your system of equations and you're taking out just all the numbers. So you're leaving the x, y, and the equal sign out, and you're just looking at the coefficients. This vertical line here represents the equal sign, and it just separates the left side of the equal sign from the right side of the equal sign. So our goal is to get a 0 where this 3 is. And what we want to do is use the 2 and the 3 to make a 0. So if we follow this rule that we want to turn the numbers into the same thing and subtract, the 2 and the 3 can both be turned into 6. If you multiply this one by 3 and this one by 2, notice I'm just multiplying them by each other, then I turn them both into a 6, and then I can subtract. So I get this new matrix in the middle here, and this is 3 times row 1, and this is 2 times row 2. So I'm going to take 3 times all the numbers in the top row. So I get 6, -9, 12. And then I take 2 times all the numbers in the second row, and I get 6, -8, 10. So make sure you do it to the whole row. So I get this new matrix with these new numbers in it. They're really the same 2 rows. They're just multiplied by numbers that make the numbers a little bigger. But now I'm going to subtract. Because I've got the 2 6s in the first column, when I subtract these rows, I'll have 6 minus 6, and I get the 0 that I want. Then I'll have -9 minus a -8, which is -9 plus 8, so I get a -1. And then 12 minus 10 gives me a 2. So 0, 1, -2 is going to become my new second row in the matrix. The top row, the 6, -9, 12, can go back to what it was before, the 2, -3, 4. Because I really just needed that top row to give me the 0. So I don't need to leave it in the 6, 9, 12 form. I can reduce it back to 2, negative 3, 4. So why is that 0 helpful? So now that we have this 0 here, if we put this second row back into equation form, it says 0x minus y equals 2. So remember, this is the x column, this is the y column, and this vertical line here is the equal sign. So the second row turns into 0x minus y equals 2, which is this, negative y equals 2. And from that, you can solve for y. The top row becomes 2x minus 3y equals 4. So it's this equation. So that 0 is nice, in other words, because it's going to allow us to solve for y. So once we solve for y, from this, you can take that y value and put it into the top equation, and you'll get a value for x. Okay, so you can finish it from there. So go ahead and finish that one. And you know what the answer should be, so just verify that you get the correct answer. So let's look at this next example. We've got this system of equations, and we take the coefficients out of there, and we get the coefficient matrix. I want to point out that you need to make sure that you keep the negatives with any of the numbers. So we got this negative 5 here, that's important. So we want a 0 where the 7 is, and we're going to use the 5 and the 7 to get that 0. So if you think about turning those into the same number, 5 and 7 can both be turned into 35 by multiplying them by each other. So we're going to multiply the 7 by the 5 and the 5 by the 7. So when we take 7 times row 1 and 5 times row 2, we're going to get a 35 and a negative 35. Don't forget to multiply the whole row. So we're going to multiply this whole top row by 7. So we get a 28 and a 119 also. And then you're going to multiply this whole second row by 5. So you're getting 35, 15, 10. So we've got a negative 35 and a positive 35. In order to get a 0, we're not going to subtract, we're going to add these two rows together now. So add the negative 35 and the positive 35, you get 0. Add the 28 and the 15, you get 43. Add the 119 and the 10, you get 129. So this is our new second row, and the top row can go back to what it was before. So we can reduce that back down to the original top row of negative 5, 4, 17. And the second row now has the 0 where we want it, 0, 43, 129. Now again, that 0 is good because if you rewrite this bottom row as an equation, you get 43y equals 129. And from that, you can solve for y. Once you solve that for y, you can take your y value and plug it into the top equation that you get from this top row, which is right here, and you'll get your x value. All right, so y'all can go ahead and finish that one. Find your y value, plug it into the top equation, get your x value. So we really just wanted 1, 0 there because we just have an x and a y. So once you get 1, 0, you'll get one of your variables, and then you get the other one. So here's another example. This system of equations gives us this coefficient matrix. We're looking at the 2 and the 4. We could multiply them by each other and turn them both into 8, but we can also find a smaller number that they both go into. They both go into 4. One of them already is 4. So we don't have to change the bottom row. The bottom row stays the same. It's already a 4. The top row we need to change into a 4, so we multiply the top row by 2. 2 times row 1 will give us 4, 6, 10. And now we've got a 4 and a negative 4. In order to make a 0 out of that, we're going to add them together. So we're adding these rows. So we add the 4 and the negative 4. We add the 6 and the 9. We get 15. We add the 10 and the 7. We get 17. So you're adding in all places across that row, across all the columns. Add, right? And that becomes our new second row, 0, 15, 17. The top row can go back to what it was before, the 2, 3, 5. And this bottom row with the 0 allows us to solve for y. So you can solve that for y now. And then once you solve that for y, you can plug your y value into the top equation that you get from the top row, and you can solve for x. All right, so y'all can go ahead and finish that one. And notice these are really easy to solve. These systems of equations with two equations, you're just trying to get 1, 0. And once you have 1, 0, you get the solution. If we have three equations, it's slightly more complicated, but we're going to follow the same steps. So if we take this system of equations, notice that it's got three equations in it. And notice also that you've got an x, y, and a z now. So you've got x's here, y's here, and z's here, right? Now I left some spaces so that everything would line up. So notice this second equation doesn't have an x in it. The top equation doesn't have a z in it. So I made sure that everything lines up. And the reason for that is that when we put it in the coefficient matrix, we want to make sure that we leave those spaces. So the coefficients for the top equation will be 1, 2, 0, 4. Because there's no z value, I need this 0 right here. In the second equation, there's no x coefficient, so I need this 0 right here. So make sure that if you're missing some variables in your equations, that you put the zeros in the right places. That's why it helps to line things up the way I wrote it this way. X, Y, and Z lined up in columns so that you get an X column, a Y column, and a Z column. All right, so to reduce this, we still want to get some zeros, but now where we want to get zeros are in this lower triangle, right down here. So we want those three places to be 0. One of them is already a 0, so that's nice. We just need to get a 0 here where that 1 is, and here where that 3 is. All right, so you're always going to start with the first column. You would use this number to make that a 0. But it's already a 0, so we're done. Then you're going to use this number to make this one a 0. So in order to do that, the top two rows are not going to change. So I'm just going to rewrite those. The only row that's changing is the last row. I'm trying to get a 0 right here. So in order to get a 0 right there, using the 1 that's above it, I can just subtract those to get a 0. So I'm going to take row 1 and subtract row 3. So I'm going to write that here as a formula, row 1 minus row 3. So over on the side, I can do this calculation. Here's row 1. Here's row 3. Oops, copied it down wrong. There should be a negative 2. So this is row 1 and row 3, and I'm subtracting. So remember that you're going to subtract in all of those places. So 1 minus 1, 2 minus 3, 0 minus a negative 2 is really 0 plus 2, and 4 minus 5 is negative 1. So this is my new third row. 0, negative 1, 2, negative 1. All right, so make sure you're careful when you're subtracting, especially if you're subtracting negatives. So there I took row 1 minus row 3, and notice it gave me the 0 where I wanted it. So now I have the 2 zeros in that first column. Now I need to get a 0 here. And I'm going to use the number that's right above it. So I'm going to use this number here to get a 0 right here. So I have to use the second row in order to do that. if I try to use the top row, if I try to use the 2 to make this a 0, then it's going to mess up this 0. So whenever you're trying to get the 0 in this bottom middle position, you have to use the number that's right above it. So I'm dealing with a 1 and a -1. So that's easy to combine into a 0. Just by adding those together, I can get a 0. So I'm going to take the second row and the third row, and I'm going to add them together. So I'm adding in all these places. 0 plus 0, 1 plus -1, -1 plus 2, and 0 plus -1. This is going to be my new third row. So the top 2 rows are not changing. The last row is going to become 0, 0, 1, -1. And I got that by taking row 2 plus row 3. I added the second and the third row here to get this new third row down here. All right, so notice I've got the zeros where I want them in this lower triangle. So I've reduced the matrix to what I wanted. I wanted the zeros. And the reason those zeros are good is that now you're going to start at the bottom and you should have one of your variable values. If you think about what this bottom row looks like in equation form, it looks like 0x plus 0y plus 1z equals -1. So this 1z is really just z, right? So from that you get a z value. You've got z equals -1. And then you can put that into the equations above it. This equation is 0x plus y minus z equals 0. So once you have a z value, you can put it in there and get a y value. And then you can take both of those values and put it into the top equation. This top equation never changed. This is x plus 2y plus 0z, which we don't have to write, equals 4. So once you start at the bottom, you get a z value, plug it into the middle one, you get a y value, and then you can plug both of those into the top equation to get your x value. So you're going to substitute starting at the bottom and work your way back up. Okay, so you can finish that one. So go ahead and finish all of these that we didn't start. Just show all your work to get your answers. And that's what you're going to submit for today. And otherwise, you'll have a homework assignment posted where you're doing those similar matrix row reductions. All right, I hope that's helpful. Have a good day.